Hello everyone, welcome back to HackProKP. In this session, we are going to learn more about DNS, that is Domain Name System, in our Cracking OSCP, your roadmap to ethical hacking success series. All the important files and all the important notes are being shared in the GitHub repository. So I would like you guys to please start this repository so that you never miss an update. What's DNS? The Domain Name System. DNS is a hierarchical and distributed naming system for computers, services, and other resources on the internet. It's a crucial component of the internet that translates human-readable domain names into IP addresses. DNS serves as a phone book of the internet. It translates domain name like www.example.com into IP addresses like 192.0.2.1 that computers use to identify each other on the network. Now let us talk about an example that will make it easier for you guys to understand what DNS actually is. Consider a boy named Billy who wants to play Call of Duty Modern Warfare 3, but the problem is that he doesn't really have storage on his PS5, so he needs to buy the physical copy of this game. Billy gets an idea that he will buy the game from Walmart, but the problem is, where is Walmart? He is new to this town, because of that he doesn't really know where Walmart is actually located. Billy opens Google Map and searches for Walmart near me. He was able to find Walmart's address and right now he is planning to go and visit Walmart to buy his favorite game. Billy actually got the game and right now is enjoying his favorite Call of Duty. Quick question for everyone. Do you think that Billy would be able to find Walmart's address if he didn't had Google Maps? Now let us come back to the topic and learn more about DNS. Hierarchy of DNS. DNS operates in a hierarchical structure organized into zones and domains. At the top level, there are root servers, which store information about the authoritative name servers for top level domains, TLDs, like .com, .org, .net, .in, etc. Beneath the TLDs are second level domains, SDLs. Components of DNS. DNS Resolver. This is the client-side component of DNS. When you type a domain name into a web browser, for example, the resolver is responsible for querying DNS servers to find the corresponding IP address. DNS servers. These servers store DNS records and respond to DNS queries from resolvers. There are several types of DNS servers, including root servers, TLD servers, authoritative DNS servers, recursive DNS servers. Root servers. These servers are responsible for directing queries to the appropriate TLD servers. TLD servers manage top-level domain information. Authoritative DNS servers. These servers store DNS records for specific domains and provide authoritative responses to queries about those domains. Recursive DNS servers. These servers perform DNS resolution on behalf of clients, recursively querying other DNS servers until they find the IP address associated with the domain name. Now we will talk about different type of DNS records. Common type of DNS records include A record. Here A is not an article, it is the type of record, so please be careful. This type of record maps a domain name to an IPv4 address. This is the most common DNS record. AAAA records maps a domain name to an IPv6 address. CNAME record or canonical name record. This record creates an alias for a domain name. MX records specifies the mail servers responsible for receiving emails on behalf of a domain. TXT record stores arbitrary text data often used for verification or authentication purposes. Now you can see an image related to complete DNS lookup and web page query. The user has searched for example.com. These are the steps that happen before the actual request to the server is sent. Now we will talk about this in detail. DNS resolution process. When you type a domain name into your web browser, Your DNS resolver sends a query to a recursive DNS server. The recursive DNS server starts by querying the root servers to find the authoritative name servers for the appropriate TLD. It then queries the TLD servers to find the authoritative name servers for the domain. Finally, it queries the authoritative name servers for the domain to obtain the IP address associated with the domain name. Once the IP address is obtained, it is cached by the recursive DNS server for future use, and the resolver can then connect to the desired IP address. Now let us talk about DNS caching. To improve performance and reduce DNS query traffic, DNS servers cache the results of previous queries. Caching occurs at various levels, including the resolver, recursive DNS servers, and even within Internet Service Providers (ISP) networks. Cached DNS records have a time to live, that is TTL value, which specifies how long the record can be stored before it expires and must be refreshed. Now we will talk about DNS security. DNS is vulnerable to various attacks such as DNS spoofing, cache poisoning, and DNS amplification attacks. To mitigate these risks, several security measures have been developed, including DNS Sec, Domain Name System Security Extension, which adds cryptographic signatures to DNS records to ensure their integrity and authenticity. Now we will talk about DNS tools, specifically Windows commands. NSLOOKUP. This command line tool is used to query DNS servers and obtain domain name or IP address information. Syntax for this command is nslookup space domain or IP address. In this example, I will try to find the IP address of youtube.com. The address starting with 192 is a DNS server and the address starting with 142 is YouTube's IP address. Now we will use ping command. By using ping command as well, we can see the IP address of youtube.com. The ping command is a network utility used to test the reachability of a host on the Internet Protocol network. We can see that the IP address from NSLOOKUP and ping is same. Now we will see how you can flush and display DNS queries on your Windows computer. For flushing the DNS records, we will use ipconfig /flush DNS. To display all the DNS queries cached on our computer, we are going to use ipconfig /display DNS. Now we are going to look at some Linux commands. Starting with dig. Dig is a flexible tool for interrogating DNS name servers. Dig stands for Domain Information Grouper. You can see that we got YouTube's IP address again with dig command. And it also shows that this is a record. If you remember, a record means this is tied up with an IPv4 IP address. Now we are going to use host command. This command is used to perform DNS lookups and display corresponding IP addresses. Now we are going to look at nslookup command. This is although more common on Windows, but nslookup is also available on Linux systems. Now we are going to take a look at the resolve file in Linux systems. The file name is resolve.conf as this is a configuration file. We can see that the current domain name system is 192.168.241.2 and this is generated by Network Manager. Now it is lab time. I want you to visit my GitHub repository and download the Cisco Packet Tracer PKT file from the description. After you have downloaded the file, you just need to open this file with Cisco Packet Tracer. You can see that the file is opened with Cisco Packet Tracer. Now I'm going to click on the fast forward button to actually save some time. You can see that there are multiple PCs and servers in this network. Now we are going to take a look at the servers. You can see that the middle server is named as DNS because this is the server that is going to handle all the DNS queries. You can see that the MSN server is hosting a website and has HTTP and HTTPS protocol enabled. Now we're going to take a look at the DNS server itself. Clicking the server and opening services, we are able to see that DNS servers is on. The actual DNS record is also shown with all the websites with the type of record stored and the IP address. Now I will open a web browser in PC1. For that, I will go in desktop and click on web browser. I will also turn on the simulation mode so that we can see what is happening step by step. Now you can see the web browser has successfully opened. Now I am going to type www.msn.com to visit the website. You will see a packet is generated on PC1. Opening the packet, and we can see that this is a DNS request packet and this is a A-type request. If we open the inbound PDU details, we can actually see the DNS query as well. Now we are going to go back to the OSI model and click on next layer. We can see on layer 4 the device encapsulates the PDU into an UDP segment. On layer 3, that is network layer, IP header, source IP address and destination IP address are added. On layer 2, that is data link layer, the device encapsulates the PDU into an Ethernet frame. And on physical layer, that is layer 1, fast Ethernet 0 sends out the frame. Now I will pass the packet to the next hop by using the forward button. I am going to increase the speed here so that the packet travels fastly. The green checkmark indicates that the DNS request has been successfully fulfilled and answered by the DNS server. We can see in layer 1 that port fast Ethernet 0 has received the frame. Now on layer 2 we can see that the device decapsulates the PDU from the Ethernet frame. In layer 3, that is network layer, we can see that the IP address header shows the source and destination IP addresses. In layer 4, we can see that the device decapsulates the PDU from the UDP segment. Now we can see on layer 7 that the DNS client receives a A-type DNS response. Now we are going to check the details in inbound PDU details. And right now on the screen we are able to see the DNS query and the DNS answer. The IP address is also included in the field below. We can see that a green packet has been created on PC1. This is a transmission control protocol synchronization packet. The server is going to acknowledge this packet and send the acknowledgement back to the client. When the acknowledgement is received, two packets are generated, with one being the acknowledgement and one being the HTTP request. The purple packet is right now having the HTTP response, and we are able to see the response of the website on our web browser. Alright hackers, that's a wrap for today's session. If you found value in this video, leave a like, share it with your fellow hackers and comment below your thoughts. Don't forget to subscribe for more content that will propel your hacking journey to new heights. Thank you for joining me today on HackProKP. I am Kailash Parshad, and until next time, happy hacking!